All right, fantastic. Okay, good morning. Maddie, you made it just in time. Good morning, everyone. This is April 28th, Tuesday. Happy Tuesday morning. This is A3 Precalculus CP. I hope you're all having a fantastic day so far on this Tuesday. I'm particularly excited today as JT came in. Hello, hello. I'm particularly excited because today we are going to be doing proofs with trig identities. And you might be like, oh boy, proofs with trig identities. I know, you can just try to contain your excitement. Actually, what we're going to be doing today is, in my opinion, easier in a way than dealing with just the straight simplification problems that we've been doing before. And you might be like, Mr. Giorgio, that's just because you're a math nerd. Proofs, easy. Usually those two words don't go together. But the thing about proving identities is that proofs actually give you a goal to work towards. You want to prove that something is equivalent to something else. All right, versus just the open-ended simplification problems that are kind of just go until you can't go anymore, almost like a little bit of a puzzle. So that's why I think proofs are particularly a little easier, because they're a little more directed. Like, you're trying to get from this starting point to this ending point. So that's what we're going to be talking about today. Hello, Ashlyn. Thanks for coming on by. Just a couple of reminders before we get started, as per usual. Make sure your webcams are disabled. Make sure your mics are off. Everybody's gotten used to that, which is great. Make sure you fill out the attendance form on Google Classroom. Very important that you do that so that you're marked present for the day. The other thing I wanted to tell you is the progress assessment. So thank you to everybody who submitted that on time. I appreciate that. The progress assessment is graded. It's in Aspen. The answer key is posted on Classroom. There were two versions of the assessment that went out, so depending on which version you have, you should be able to look at the answer key and figure that out pretty quickly, which version was which. What else do I want to tell you? Oh, if after looking at the answer key you have any more and you look at your grade and you have any more specific questions where you want me to say, hey, why did I get points off here, or why did you give me credit for this, or hey, do you mind going over this problem again with me? Absolutely, no problem at all. I'd be happy to do that during any office hour time. Okay, I'll be after all my office hours. I'm just sitting here in the Google Meet. Sometimes people join me, and sometimes they don't. Either way, I'm here for you. So please, please, please do not hesitate to reach out if you need me. All right. So that being said, today I want to show you how to handle these good old proofs. All right. I know that's the forbidden P word in math, proof. But again, like I said, the thing I think is nice about proofs is they give you a direction to work towards. Yes, some of them can be pretty tricky, but for the most part, you're just trying to show that two things are the same. All right, let's start with an example like this. Okay. Oh, so I should probably say this. I should say that the goal is you're trying to show, blend that in there, that both sides of an equation are equivalent. Okay? That's how our normal identities work. We're saying that sine squared plus cosine squared is 1. That's an identity. We've shown that those are equivalent. We've proven that actually together as a class. So now we're just trying to do, hey, here's a bunch of random ones. Can you show that both sides are equivalent? In order to accomplish that, you can either do one of two things. Okay? You can show that the left-hand side equals the right-hand side. Or I'm sure you can imagine what the other option is. So you can show that the left-hand side equals the right-hand side, or you can do the other way, where you can show that the right-hand side equals the left-hand side. Whichever direction you proceed in is fine. A lot of times in a problem, one way will kind of lend itself to be like, hey, this is the way you should probably go about it, where you have this one really complicated side of the expression and one really easy side, and you're probably like, hey, I want to take that complicated side and simplify it down to the easy side. So sometimes it's pretty obvious. When it's not obvious, generally you can kind of pick which side do you want to work with. Sometimes You might get stuck working with one side, and then you might be like, hey, let me try working with the other side instead. So let me show you an example just so you can see what I mean. Okay, here's a classic proof that you can deal with, right? Let's show, so prove that 1 over 1 minus sine squared of x is equal to 1 plus the tangent squared of x. Okay? Now, what you could do with a problem like this is you could either show that the left equals the right. So you can say, let's take this and make it look like that. Or you could do the other way where you could take this and say, hey, let's make this look like this. All right? I'll show you both ways. So the first way is if I'm saying, let's work on the left-hand side. The way that that's usually abbreviated is LHS, stands for left-hand side. Okay? So just by writing LHS, that's an indicator to me and an indicator to yourself that I'm working with the left-hand side. Okay? So if we're working with the left-hand side, we could say, well, ooh, look at the denominator of that expression. 1 minus sine squared. Well, that's a Pythagorean identity. We could say 1 minus sine squared. You see it's the first equation down right below me. 1 minus sine squared is equal to cosine squared. So I can rewrite this as 1 over cosine squared of x. We're just working with the left-hand side. And I'm trying to make this look like this. Okay? Well, 1 over cosine squared, let's refer to our reciprocal identities. We could say that that's the same as the secant squared. Right? So we know that that's that, and we know that that's the same as that. Now, using, again, your Pythagorean identities, ooh, look at the last Pythagorean identity right below me. Tangent squared plus 1 is equal to secant squared. So I can now rewrite this as tangent squared plus 1, which now equals the right-hand side. I'm going to note that as now this equals the right-hand side, and therefore your proof is complete. You've shown that this is the same as this, which clearly equals the right-hand side. So our proof is done. Remember, you have your good old proof signature. Got to put it at the end of every proof. Hopefully you can bring it all the way back from when we did proofs before. Again, I was trained a lot of times just using the little box and filling it in as the proof has been completed. My personal signature that I like, though, is a little Triforce. But hey, you can do whichever one you like. All right? But bring back that proof signature. Very important. Okay? Now, you could have gone about this problem. That's one way to do it. You could have also gone about this problem the other way, where you could have said, well, let's start on the right-hand side, abbreviated as RHS, and let's see if we could make that look like the left. So 1 plus tangent squared, you're going to notice that the steps are almost the same, just in reverse. So 1 plus tangent squared, you could look at your Pythagorean identities and say, oh, well, that's the same as secant squared. I know secant squared. We could rewrite it as that. Using your reciprocal identities, you could say, well, if I want it to look like a fraction, we should probably make it a fraction. We could say, well, that's 1 over cosine squared. And then using your Pythagorean identity, you can recognize that cosine squared can be rewritten as 1 minus sine squared. Because see how that's just a manipulation of the equation? The first line of Pythagorean identities right below me. You could say, well, that's the same as 1 over 1 minus sine squared. And that now equals the left-hand side because they're the same, and therefore we've proven that these are the same. So you can write your little proof signature down there. Call it a day. Okay. Does that make sense to everybody how that's done? Again, two ways that you can go about it. You could pick either one. You don't have to do both. Just pick either one of those ways. All right. Like I said, though, a lot of times it's pretty obvious as to which way you want to proceed. All right, so let's just do a couple easy ones. Then we'll get into one that's a little harder, and that'll probably be it for today. We'll do a lot more on Thursday. I will give you some practice to do in the meantime as well. Okay, how about something like this? Ready? A couple examples. Let's do something like this. How about tangent of x? And by the way, I'm using x now. You could certainly use theta if you want to use theta. I might go back and forth. Times sine of x plus cosine of x is equal to secant of x. And we want to prove this. Okay? Well, if I want to prove that this expression is equal to this, it makes a lot of sense to me to work with the left-hand side because it's a lot more complicated. If I'm just starting on the right-hand side, I don't really know where to go, and it's really just secant. Like, there's really not much I can do with it without just, like, adding stuff onto it randomly. So let's work with the left-hand side and try to make it look like the right. So let's work with the left-hand side. Okay. What I could do, let's see. Well, we could probably change tangent to sine and cosine. So let's do that. Let's make it sine of x over cosine of x times sine of x. And then plus cosine of x. So just rewrite the left like that. We're aiming for this goal. This is our goal. Well, now I can combine this a little bit. Sine of x times sine of x is sine squared, and that's over cosine. So now I have, on the next step, we could say, well, this is sine squared of x over cosine plus cosine. Now, hopefully, what's kind of going off in your head, a little alarm, is that you should say to yourself, ooh, I want to make sure I get a common denominator, because I would love to stick these things together, right? This is cosine of x over 1. So in order to do that, we need to make sure we multiply this side by, or this term rather, by cosine over cosine. Because your least common denominator that you're gunning for is the cosine of x. All right. So if we do that, what is this now going to look like? We could say this is now sine squared of x over cosine squared of x plus cosine squared of x over cosine, oh sorry, not cosine squared, my fault. Sine squared of x over cosine of x, my fault, don't want to confuse anybody. Sine squared of x over cosine plus cosine squared over cosine, right? Because I just threw a cosine on the top and the bottom. I didn't change this. Now these both have a common denominator of cosine, so I can stick them together and say, well, this can be rewritten as sine squared plus cosine squared over cosine. Okay. Sine squared plus cosine squared, though, hopefully you're like, ooh, well, sine squared plus cosine squared is just 1, right? So we can now take this and rewrite this as 1 over cosine of x, because sine squared plus cosine squared is our Pythagorean identity. And what's 1 over cosine? Well, 1 over cosine is the secant of x, right? And so now you're like, ooh, well, secant of x, that's what the right-hand side was. And we've now proven that this all works out. Okay? Does that make sense? So again, I kind of like the fact that it gives us a goal. Essentially, it's giving us something to work towards. And that's why I think proofs sometimes can be easier, arguably, maybe not by much, but easier than just straight simplifying. Because sometimes when you're just straight simplifying, it's hard to tell when you're done. Like, do you end it when you get down to 1 term? Do you end when you get down to 2 terms? It can be difficult to tell. But when you're working with a proof, it's very clear as you want this to look like this. There's no mistaking it. If I don't get this to look like this, then I haven't succeeded. Okie doke. All right, let's give another problem a try. Yes? Let's do a couple more. I have time for a lot more, actually. Here we go. How about one like this? Ready? Let's say I want to prove. Yeah, we can do this one. Okay, let's say we want to prove that tangent squared of theta is equal to cosecant squared of theta times tangent squared of theta minus 1. Okay, I want to prove that that's the same. Okay, again, hopefully it's obvious to you to start as to which side you want to start on. Yes, you could choose to start on either side. You could change tangent squared if you wanted to secant squared minus 1 and see if you can get anywhere from there. But I'd probably start on the right-hand side. So I'm going to work with the right-hand side. Okay? Let's see. Cosecant squared times tangent squared of theta, and then all minus 1. Probably what I would want to do with this is change it to sines and cosines so I can see some canceling out. That seems to be a good strategy because I don't really have anywhere else to go. Keep in mind I couldn't take tangent squared minus 1 and turn it into secant squared because this is stuck together. So let's change it to sine and cosine. Let's see. Cosecant squared is 1 over sine squared. We know that by our reciprocal identity. Tangent squared is sine over cosine. Sine squared over cosine squared. And then I have this minus 1 still stuck here. Well, hopefully by doing that, you're like, ooh, wait a minute. Sine squared over sine squared is going to cancel out. That gives me now 1 over cosine squared of theta minus 1. Well, 1 over cosine squared immediately should be screaming to you, ooh, reciprocal identity. That's secant squared of theta minus 1. And now secant squared of theta minus 1, that's our Pythagorean identity. We know that that's the same as the tangent squared of theta. We've now shown that that equals the left-hand side, and we're done. Okay. Question about that? Okay, excellent. Let's do another one. Let's keep going. Keep going. Keep going. How about this? I like this problem a lot. How about prove that the cotangent squared of theta over cosine squared of theta minus 1 is equal to the cotangent squared of theta. Very similar to the problem we just did up there. Okay? We're going to try to prove that. Hopefully, again, you're recognizing the fact that which side should I start on? What side do I actually want to work with and try to aim towards the other side? I'd probably want to work with the left-hand side, so let's start on the left-hand side. Okay? I usually think it's somewhat obvious to tell. I know in the example that I started showing you, I made it kind of ambiguous on purpose, but for the most part, it's going to be pretty obvious which side I want to start working on. It's generally the side with more stuff on it, with more to do. So let's start on the left. Here I have cotangent over cosine. Well, cotangent I can rewrite at, when I don't really have anything else to do, let's try to change it to sine and cosine. I can write cotangent squared of theta as cosine squared over sine squared. That's my quotient identity. That's all being divided by cosine squared minus 1. Well, remember, if we're dividing by cosine squared, that's really the same as multiplying by 1 over cosine squared. It's a little easier, I think, to actually write this out as cosine squared of theta over sine squared of theta times 1 over cosine squared of theta, and then minus 1, just like that. See how this is the same as this? These are equivalent expressions. You could see that, oh, cosine squared over sine squared, and then all divided by cosine, that's the same as if you just multiplied it by 1 over cosine. I think it's beneficial to write it out that way because then you can notice, oh, cosine squared and cosine squared is going to cancel out. I'm now left with, this is one term, by the way. Very common mistake. Everyone's going to be tempted to do 1 minus 1 and get 0. This is its own thing. This is its own thing. You can't just stick these together. I get 1 over sine squared minus 1. Very similar structure to what we saw before. 1 over sine squared is cosecant squared of theta, and then subtract 1. We could see in our lovely Pythagorean identities down there, it's just a manipulation of that middle equation. Think of if you subtract 1 from both sides, you're going to get that that's the same as cotangent squared. Okay. And cotangent squared, that's what we've shown. That's equal to the right-hand side. Therefore, our proof is complete. Okay. Again, proof signature, very important, don't forget. Okay? Typically the box, that's what a lot of people do. That's how I was trained in college, was to use the little box that you fill in. I've also seen QED. It's Latin, I forget what it stands for, but it means that's that which has been demonstrated. I don't remember what the actual Latin expression is, though. Sorry, I know I'm on video, I don't remember. For the record, I don't remember. All right, anyway, question, comment, concern about that? All right, let's do a couple more. Let's get into some more difficult ones. Ready? Let's do, trying to get some paper. The paper's all stuck together. Here we go. Let's get into some ones that maybe involve a little more work. All right, a couple more steps. How about something like this? Let's try to prove that sine of theta plus cosecant of theta all over cosecant of theta is equal to sine squared of theta plus 1. All right. So again, it's not super clear as to what side I want to start on. You may just try to start on one side, see if you can go anywhere, and you might be like, oh, that didn't really get me anywhere. Let's switch to the other side. For example, what I might do here is I might be like, well, what if I tried to start on the right? I might be like, well, I could make sine squared to be 1 minus cosine squared. Then I get 2 minus cosine squared, because 1 plus 1 would be 2. But that doesn't really take me towards my goal. Do you kind of see that? So let me write it out for you instead of just explaining it. So what I could try to do, what you may be inclined to try, is you say, well, what if I try the right? I could say, well, sine squared is the same as 1 minus cosine squared, so we could change this to 1 minus cosine squared plus 1. Now 1 plus 1 is 2, so you get 2 minus cosine squared, but it doesn't seem like that's going to take us in this direction. Do you see that? So like you kind of go from there, and you don't really have a direction that's getting towards here. So if you encounter that, that's okay. That doesn't mean like the world's falling apart. It doesn't mean you should cry or panic. It just means, well, let's try working with the left instead. And that's exactly what I would do here. Okay. Working with the left, one thing that I could do is I could split apart that fraction. We have sine plus cosecant all over cosecant. Let's rewrite that as sine of theta over cosecant of theta plus cosecant of theta over itself. And we want that to equal sine squared plus 1, right? Well, now cosecant over cosecant, hopefully you can see, just comes out to 1. So we now have sine of theta over cosecant of theta plus 1. You might be like, oh, that's good. We got the plus 1 that we were looking for, so I'm happy with that. Now, how do we deal with sine over cosecant? Well, cosecant, if you remember, is 1 over sine. So I have sine of theta divided by 1 over sine, and then plus 1. Well, how do you divide by a fraction? You multiply by the reciprocal. We're going to do exactly that. I have sine of theta times the reciprocal sine of theta over 1 plus 1. Look at what that comes out to be. Sine times sine is sine squared. Sine squared of theta plus 1, which now equals my right-hand side, and so I'm happy my proof is done. Okay, we've shown that this side is the same as that. All right. Now, that doesn't mean that this problem is impossible to approach from the right-hand side. Just trying to do it off the top of my head here. If I had approached it from the right-hand side, you probably have to do a little more sneaky math tricks, but certainly probably could do it. Let's see, I could write sine squared as 1 over cosecant squared, right? Maybe now I could find a common denominator. Oh, rats, this is going to be hard. If I find a common denominator, we could say this is 1 over cosecant squared. I'm going to try it. It may fall apart, though. We'll find out. Going off the cuff here, right? Now we're going to try to combine these together. Let's see, we could write this as... Oh, rats. Oh, you know what I'd probably have to do? I'd probably have to now split apart. Like, what you could do is you could cancel out one of the squareds on the cosecant squared. And so you could say, well, this is cosecant over cosecant, which is kind of what we want here. And then you could say, oh, well, 1 over cosecant squared. Let's write this as 1 over sine squared times cosecant squared. This is sneaky stuff, though. Then the 1 over sine squared will flip up to the top. So I have, but how do we get rid of the squared? How do I get rid of the squared? You see how I still have a squared there, though? How do I actually get rid of that? I'm not quite sure. Or maybe it's beneficial to keep that in there, because then you'll have sine squared cosecant. I don't know. See, that's what's tricky, though, going on this side. I knew I should have probably prepared that. I know it's possible to do from the right-hand side, but it's significantly harder. And hopefully my struggle right now, which is recorded for the whole world to see, hopefully my struggle right now is a little bit of a proof in and of itself that it's a little harder to go from the right-hand side. And if you try to go from the right-hand side, there is a way to do it, I'm sure. I'm sure if Mr. Danzero watches the video back, he'll be like, Mr. Giorgio, you fool. It's very easy. You just do it like this, blah, 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 and it's done. But in any case, it's harder. So that could be an indication to you to say, I'm not getting anywhere. I'm getting nowhere here, or I'm like starting to make stuff up. So let's go to some other side and let's try to work from the left. Okay? Hopefully that was just a big example of don't feel like a fool. Don't give up. Just switch sides. See if we can go from the left. Let's do another one. Save ourselves from that problem. Ready? Ooh, how about this problem? Let's do... This one's a little trickier. How about sine of theta plus cosine of theta all squared plus sine of theta minus cosine of theta all squared is equal to 2. That's a cool problem. I like that. Hopefully it's obvious that we should start by working on the left-hand side. So let's start with the left-hand side and go from there. I'm really determined to figure that out. I will. I'll figure it out. I'll post it on Classroom maybe. What I'd want to do here, notice that this sine plus cosine squared is not the same as sine squared plus cosine squared. It's the same reason that this is not the same. X plus y squared is not the same as x squared plus y squared. In order to take something like this and square it, what does it mean to square something? We have to multiply it by itself. This is the same as x plus y times itself, x plus y. Okay? When you distribute, you're going to get x squared plus 2xy plus y squared. And so that's exactly what we have to do over here. We can't just say, oh, that's sine squared plus cosine squared. That's sine squared minus cosine squared. That's not going to help us at all. We have to make sure we distribute. So I'm going to do sine of theta times cosine of theta sine of theta plus cosine of theta times itself. Sine theta plus cosine times another sine theta plus cosine, because that's what it means to square something, right? It means to multiply it by itself. Okay? I have the same thing going on over here. Sine theta minus cosine theta times itself, another sine theta minus cosine theta. Okay? Let's distribute. Here we go. We got sine times sine, which is sine squared. Sine times cosine is plus sine theta cosine theta. Here I have another one in the middle, notice, plus another sine theta cosine theta. Last, cosine times cosine is cosine squared. Okay, let's do the other one over here. Write it on the same line. Sine times sine is sine squared. Sine times the opposite of cosine is minus sine theta cosine theta. Negative cosine times sine minus, again, sine theta cosine theta. And negative cosine theta times negative cosine theta is positive cosine squared of theta. Okay? Now that looks like a lot of stuff, but look at what happens with all that lovely stuff. Sine cosine, negative sine cosine, those go away. Sine cosine, negative sine cosine, those go away as well. Look at what I'm left with. I'm left with sine squared of theta plus cosine squared of theta. That's this and this. I also have another sine squared of theta, that's this, plus cosine squared of theta, which is this. Okay? Ooh, well, look at that. Couldn't line up any better. Sine squared plus cosine squared is 1 according to our Pythagorean identity. Sine squared plus cosine squared is 1 according to our Pythagorean identity. 1 plus 1 is 2. Okay? And therefore, we've shown that that's the same as the right-hand side, and we've proven what we need to prove. Okay? Any question, comment, or concern about how that is done, even in the slightest? No question at all? We're feeling great? Feeling happy about that? Now I'm really determined to do this. I'm going to do it. I'll do it. I don't know how. We'll figure it out, though. But see how much easier it is to go from the left than to go from the right? I know, I'm still hung up on that. I shouldn't still be hung up on that. I should just let it go. I should just let it go. I'm not going to be able to let it go. It's going to drive me crazy during my whole lunch hour. Anyway, that's all I got for you guys today. Thank you so much for your attention and focus. I do have some practice problems that I'm going to post on Classroom for you. I would highly recommend, with the answers, I'd highly recommend doing them prior to Thursday's class. Okay? See if you can give them a shot if you have the time. It's only to your benefit. On Thursday, again, just like we did this week, there is going to be a progress assessment sent to you via email. That's going to be due Sunday night. Okay? Same schedule, same routine as before. If you have any other questions or concerns, please do not hesitate to reach out. I do hope you have a fantastic rest of your day. Hopefully, proofs are not so scary. It really just gives you a goal that you have to aim for. So I actually think, in a way, you may not believe me, proofs are almost doing us a favor. They're pointing us in a direction rather than just leaving it open-ended. I don't know. Take it as you will. Have a great day, everyone. I will see you on Thursday. Enjoy the rest of your Tuesday.
Bye, Mr. Giorgio.
See you later.
Have a good day.
See ya.